All right, today we're going to dive into a feeling you've definitely had, a ghost that, believe it or not, lives in every single car, and a huge physics mistake that has somehow become a part of our everyday language.
You know the feeling, right? You're just sitting there, riding shotgun, the driver hangs a sharp left, and suddenly you feel this undeniable push slamming you into the right side door. So what is that force? I mean, where does it even come from?
And it's not just you, it happens to everything. Your phone, that old cassette tape you've got on the dash, even your groceries in the backseat. The second the car turns, anything that's not tied down just slides to the outside of the curve. And, we all have the same explanation for it. But here's the thing. That common explanation, the one that we all instinctively reach for, it's completely 100% wrong. So what is this phantom force we all feel? Let's take a closer look at the ghost we tend to blame for all this weird behavior. Yup, that's the one, centrifugal force. But according to physics, well, it's a ghost. It literally does not exist. It's a made-up force, a fake, that we invented just to explain a feeling. So if there's no center fleeing force pushing you outwards, what in the world is actually going on? To really see the truth, we just have to change our point of view. It's time to step out of the car, so to speak, and look at the whole situation from a completely different angle. Okay, so check this out. This is where it gets really interesting. On the bottom, that's the view we all know, right? It totally looks like the tape is being pushed sideways. But look up top, the bird's eye view. From way up here, the real story unfolds. The tape isn't being pushed anywhere at all. The real star of the show here is inertia. It is one of the most basic ideas in all of physics. Your body, that tape, everything that has mass has inertia. And all that means is that it wants to keep doing whatever it's already doing. If it's moving, it wants to keep moving. And here's the key, in a straight line. So here's the mind-blowing part. There is no outward push. None. Instead, what's happening is the car is turning inward, literally turning out from underneath you. And your body, thanks to good old inertia, is just trying to keep going on its original straight path. The side of the car door then gets in your way and it pushes you into the turn. So the actual force we should be talking about is centripetal force, which basically means center seeking. For the car to make the turn, the friction between the tires and the road provides the centripetal force it needs to pull it into that curve. For you, it's the car door pushing you inward. But for that tape on the slippery dashboard, there just isn't enough friction, not enough centripetal force, so it keeps going straight while the car turns away from it. And this whole idea of a center is super important. It's not just about forces, it's also about how things are built and how they find their balance. Let's dig into how this principle works. So, every single object, no matter what it is, has what's called a center of mass. The easiest way to think about it is as a single, unique point where all the mass of that object is kind of concentrated. It's the object's natural balance point. And this is something you can actually find yourself. It's pretty cool. Try it with a broom at home. Just put it on your 2 index fingers, start with your hands far apart, and then just slide them together. No matter what, they'll automatically meet right at the broom's center of mass, its perfect balance point. And you'll notice it's not in the dead center, but it's way closer to the heavier, brushy end. Now, when you get an object balanced perfectly on that center of mass, you've achieved something called static equilibrium. All the forces acting on it, like gravity pulling down and your finger pushing up, are perfectly balanced. They just cancel each other out, and what you get is total, perfect stability. Okay, so once you get these concepts, inertia, real forces, center of mass, you literally start seeing them everywhere. They're not just in a textbook, they're all around us. Let's look at a few amazing examples. I mean, just look at this incredible jump. A ballerina's arms and legs are moving in all these complex, beautiful ways to create this illusion of just floating through the air. But her center of mass, it's just following the same simple, predictable arc that a baseball would. The laws of physics are right there, hiding in plain sight inside the arc. Or what about on the racetrack? Drafting a NASCAR is a perfect real-world example of managing forces. The lead car literally punches a hole in the air, which makes it way easier for the car right behind it. But what's really cool is this partnership also cuts down on the vacuum dragging on the lead car, so they can both go faster than either one could alone. And oh, these balancing toys, they look like pure magic, right? Like they're just defying gravity. But the secret is actually beautifully simple. They're designed so that their center of mass is always hanging below the point where they're balanced. So if you tip it,
Gravity just creates a force that pulls that center of mass back down to its lowest, most stable point. It's not magic at all, just incredibly clever design.
It's wild, isn't it, how these same ideas pop up all over the place. But what if we zoom out, like way, way out? It turns out that all these forces we deal with every day, friction, a push, air resistance, they are all just different flavors of a tiny, tiny handful of truly fundamental forces. Believe it or not, it all boils down to just these four. First, you've got the strong force, the most powerful of all. It's what literally holds the nucleus of atoms together. Then you have the electromagnetic force, which handled everything from light to electricity. That's the force that lets the car door actually push on you. After that comes the weak force, which is involved in radioactive decay. And finally, the one we all know but is actually the weakest of them all, gravity. Every single push or pull you've ever experienced is just one of these four forces wearing a different costume. So think about it. We started this whole journey with a simple feeling, a ghost in a car. And we discovered that this centrifugal force isn't real at all. It's a phantom, an illusion created by our limited perspective inside a turning car. And that kind of leaves us with one last big question. If this common experience that we all share is just an illusion of perspective, what else in our reality might just be a matter of how we're looking at it?